Hi, my name's Ewan Thiele, and I'm the leader of the Gleam Team. Come on, let me introduce you to the rest of my team. Alan Yuen will play an investigative role and will cover the fluid delivery of the system. Yi Hao will take on a research and design role to cover his attachment method. Alexander Hawes will provide the safety and ergonomic insight as the team evaluator, and my designs will revolve around the fluid application.
Level 5 of UQ's Mansur Shore building was constructed as an extension to the pre-existing building and was completed in 2010. On this level alone, there are over 90 windows, and where there are windows, there should be window cleaners. This is not the case. Due to a number of issues, there is no current window cleaning method, and as a result, over the last 3 years, the windows have accumulated dirt, dust, and spiderwebs. That's where we come in. The Gleam team aims at designing a safe, efficient and practical system for cleaning the external surfaces of the Level 5 windows. More specifically, we aim at cleaning, which refers to the removal of dirt, dust and spiderwebs from both the windows and the horizontal sunshades located between adjoining window panels. The Gleam team also aims at devising a method that deters the spiders from returning. Sounds easy enough, right? Well, this must be done without the use of elevated work platforms or scissor lifts, and the building structure is not to be altered. The team is faced with many challenges, which all stem from the building's configuration. The windows to be cleaned are 32 metres off the ground, and horizontal sunshades separate levels 4 and 5. Additionally, the building lacks accessibility on the ground floor due to close neighbouring structures. This greatly increases the difficulty of a conventional water-fed pole, which is operated from the ground. The roof overhang is as large as 2.7 metres on the northern side. This is a major drawback as an abseiling method is performed when the roof is flush with the building's windows. Window cleaning is important from domestic applications to the tallest building in the world. The only thing that changes is the method, and a successful method is one that considers practicality, regulations, safety and cost. These factors have been acknowledged as our critical success factors and will be used in a decision-making matrix to assess alternative designs. To assist in the brainstorming and design process, the following assumptions have been made. Abseiling lugs located on the roof are able to be tested and certified as being safe for abseiling purposes. It's deemed to be unsafe for man to walk on the roof without knowledge of its structural integrity. All windows are of similar dimension. Water flowing through a hose or pole is capable of reaching 3 stories in height on hose pressure alone. And finally, windows are watertight, so no water will enter the building.
Okay, so the basic idea of this proposal was that came from us putting an extra level on this building in 2010. It's an odd-shaped building that we've got this tower in the middle and workshops and laboratories out to the side and in front. So the basic idea was, could we come up with an innovative alternative way of accessing the external surfaces of the building to clean?
Hi, my name is Alan. I am the resource investigator of the team. That involves finding the right contacts to gather external information from that can assist with our project at its various phases. As previously outlined, our proposed solution involves a central pipeline delivery method that will have features to both wash and dry each window on the 5th floor of the building. To ensure this design works, I am focusing my attention on how to deliver water and air to the 5th floor with enough pressure to clean and dry the windows. This will require fluid dynamics calculations to find the correct pump and valve spec that will fit with the structure of the building. I will also be looking at water filtering options that will provide purified water to the system. We believe this aspect is crucial to obtaining the streak-free appearance on the windows. To accomplish this, I will have to initially consider the level of purification needed for the streak-free appearance, but more importantly, what level is achievable for a particular flow rate. The effectiveness of the cleaning process will depend on the fluid delivery. Unless there is sufficient fluid delivery, the nozzles and air knives will not be supplied with enough pressure to clean and dry the windows. However, oversupply of fluid will also impact on the system's ability to support the load, which would then trigger safety concerns. So as you can see, it is critical to determine an optimal fluid delivery. The routing of the fluid will also impact on the portability of the system. I will need to make sure that the fluids are accessible on all 4 sides of the building. This will be an important feature to get right.
My name is Yuen, and my focus within the Gleam team will have 2 aspects. The first is purely organisational, and the second is to design the method of fluid application. The organisational role will come naturally and will fit in with my team leader position. The fluid application task involves a few major components. These include the design of a nozzle setup for both liquid application and air drying, a system to ensure all windows will be cleaned, and a method to ensure all parts of each window will be cleaned evenly. The nozzle setup will involve spray patterns, number of nozzles, and orientation, and will require an iterative process in order to find the best possible solution. The method to clean all windows is required because we're aiming to design a portable system. This can be done by specific prior art research and manipulation of existing carriage systems to suit the task. Quite often you see guys with pressure washers doing an up and down motion to clean the whole window. Basically, I need to figure out how to do that 32 meters off the ground. Ideally, we would want a solution where less manual labor is required and an even clean is achieved. If we can reach these 2 goals, then we would have produced a successful design, in that anyone with simple training would be able to perform a difficult cleaning task. This would provide another simple alternative to those systems in the market today. Fluid application is an integral part of this project, and if an appropriate solution isn't found, then that would directly affect the quality of the clean that we can produce. As we envision it at the moment, the cleaning process will start with fluid delivery, after which it will reach fluid application. The attachment method will ensure the facade is cleaned, while safety and ergonomics will be an integral part in each section.
Hi, my name is Yi Hao. In my team, I play the role as a researcher and a designer. At the beginning of this project, one of my major tasks was to conduct research on the existing window cleaning system, such as gathering information to find out the way that functions and the steps required to improvise that. After the team came up with a proposed design, I was assigned to develop a research method for the installation of a manifold with attached spray nozzle and super iron air knife on the roof. I was also assigned to design storage to keep the components safely after they are removed. A similar method was then developed to adapt to our project requirements. Tasks that were assigned to me had significant impact on the overall projects. One such example would be the enhancement and increased efficiency of the window cleaning system through the simple installation of manifold with spray nozzle and super iron air knife. The proposed design itself encouraged effective interaction between my team members and I. After the design was finalized, we were allocated with different parts to work on, which eventually contributed to the overall success of the project. For instance, one of the members is responsible in searching for the spray nozzle and super iron air knife, which are needed for my installation purpose. As soon as the design of axle change in the direction of spray and components movement along the surface of building is done, the work is then passed to me to build up the installation of the whole system.
Hi, my name is Xander, and I'm the evaluator within the team. I'm required to provide a logical eye when assessing design proposals. I make impartial judgments for the benefit of the team and am frequently weighing up our options. I believe that as the evaluator, I must be open to new ideas, as something worthwhile can be extracted from each and every idea. I'm constantly interacting with other members, as it is my duty to provide valuable feedback so that an idea can grow into what may be a potential solution to our problem. The Gleam team aims at putting safety above all else. We want to significantly reduce the risks and hazards associated with window cleaning. Thus, I will be focusing on the safety and ergonomic aspects of the design. The proposed pipeline design uses the application of pressurized fluid delivery as the means of cleaning the windows. I will need to ensure that the water is free to travel through the piping network. This is because unintentional clogging of the pipelines or nozzles could overpressurize equipment to unsafe levels. I will be investigating different methods of implementation, which refers specifically to setting up and dismantling of the design. Calculations on the forces, moments and loads encountered during startup and operation will be required so that the highest possible safety factor can be achieved. From an ergonomics perspective, the design almost completely eliminates the need for human labour. Thus, an ergonomic study will look into the ease at which the device can be started. The operation of the device is beautiful, in that man is not exposed to any hazards, so we want to ensure that the startup of the device doesn't re-inject man into a potentially hazardous environment by being both safe and practical. Safety is an underlying design component that affects all facets of the design process, from fluid delivery, application, to implementation and operation. Therefore, as the evaluator, focusing his attention to safety, I'll need to effectively collaborate with my fellow members to ensure a safe and feasible design.
So, now that we have heard from each member of the group talk about their ideas and how they intend on contributing towards the project, let me reiterate on what the Gleam team aims to achieve. The Manchester Shore building stands 32 meters high, and we, the Gleam team, has been asked to engineer a solution to clean the 5th floor windows along with the sunshades without the use of elevator work platforms. To tackle this, we have broken the task down into 4 key areas for each team member to look at. I will be focusing my efforts to making sure the fluid is adequately delivered to the 5th floor. Yuen will be looking at applying the fluids to the system to both clean and dry the 90 window panels existing on this floor. Next, Yi Hao will consider how the design will be installed and fitted onto the building, and finally, Alexander will overlook all sectors to make certain safety is preserved in our processes. Each year, on average, 46 fatal incidences related to work at height occur. It remains as the single biggest cause of workplace deaths. With our design, the chance of this happening will be eliminated. The Gleam team will provide a design solution that will restore the window condition back to its original polished state.